thank you to the conveners for the great session and David for multiple presentations. I'm kind of now unconformably transitioning from discussions of stratigraphy to the bits that are missing. In one of the most spectacular locations in the world for the examination of unconformities, maybe a show of hands to people that have been to Grand Canyon. Quite a few of the 6 million people a year, often representing a wide international visitorship. It's an ideal location for the place of study of unconformities. Given that it's such a classic location and that so many geologists have been there, could you look at this picture and point out a great unconformity or maybe two great unconformities? Just examine the picture. The Colorado River flowing from right to left, exposing 1.6 kilometers, over a 450 kilometer length in Grand Canyon National Park. Here we have the crystalline basement rocks beneath, tilted sedimentary rocks of Meso and eventually Neoproterozoic age. And an unconformity here on a spectacular monadnock of Mesoproterozoic sedimentary rocks with the overlying Cambrian strata of the Tonto group. So even in this photograph, you can see that there's actually some complexities well recognized in the scientific tradition here at Grand Canyon that many unconformities comprise a great unconformity. So one of the most profound unconformities on Earth with up to 1.3 billion years missing across a very narrow transition in some places. And I'm presenting, of course, the work not just of myself, many other scientists that have worked in this area, including my husband and colleague, Carl Karlstrom, who's watching over me during this presentation. And we'll be talking about Grand Canyon also tomorrow in the geomorphology section. In terms of the geographic location, you can see here on the left, the United States. In the western U.S., the Colorado Plateau is a spectacular geographic feature, and the Grand Canyon carves through the western edge of the plateau, shown in more detail on the right, reflecting the central deepest portion of the Colorado River drainage system, which is a continental scale river draining snow and ice from the Rocky Mountains all the way to the west coast of the United States. In terms of the unconformity, if you look at the map on the right-hand side, the red color is denoting the trace of the Cambrian Tonto group, which overlies basement rocks of the Proterozoic here in the western part, and of course continuing even further west past Grand Canyon into the Basin and Range. On the right-hand side, we have the Cambrian overlying Meso and Neoproterozoic rocks of the Grand Canyon supergroup. And as this exceptional geologic record of the stratigraphy over such broad spans of geologic time that allow us to understand more about unconformities and how they form. Shown here in photographic example on the left-hand side again are the different types of unconformities feeding into the classic great unconformity. On the left-hand side is a little explanation of this with the Paleoproterozoic rocks of the Vishnu basement, and then the tilted Meso and Neoproterozoic Grand Canyon supergroup, and then overlying that, the flat-lying rocks of the Paleozoic. So the unconformities coalesce as we move to the left side of the photograph, and it's perhaps there where we see the 1.3 billion years that most people conceive of as a great unconformity. But the great unconformity doesn't only denote a great amount of time missing, we also record the denudation and stripping of a great mountain range in the Paleoproterozoic and approaching Mesoproterozoic time that reflects 20 kilometers of denudation. And it's this scientific and quantification of the denudation process that's one of the most interesting scientific laboratories for studying unconformities that's represented by Grand Canyon and people that have been working in the last decades on denudation and quantification of that process. In more detail, this photograph illustrates the gentle tilting of the rocks of the Grand Canyon supergroup and lets you see the superb geologic record of that time and also of the Tonto group that then covers over rocks all the way from the Vishnu basement rocks on the left, sequentially through the Mesoproterozoic strata, and we're only seeing the base of the Neoproterozoic section, which if you straightened it out, represents over 4 vertical kilometers of Meso and Neoproterozoic strata. The rocks most people think about at Grand Canyon, the Paleozoic strata, are less than half of that extent. And that's the great unconformity as recognized by Powell. On the left side, we see geologist Mike Timmons, who's the current director of the New Mexico Bureau of Geology and a Grand Canyon geologic mapper and scientist, with his hand spanning the 1.3 billion years missing, with the oldest rocks in Grand Canyon, 1.84 billion years, the Elves Chasm gneiss, overlain by a conglomeratic layer within the Tonto group. On the right-hand side, we are then reminded that despite having one of the best geologic records of strata in Grand Canyon and the deep exposure afforded by the hard work of the Colorado River over the past 6 million years to expose that record, that in fact there is much more time missing. And the more we quantify the stratigraphy, the more the black areas seem to enlarge. And so if we think about the great unconformity and we look at the different unconformities, we see we have a nonconformity at the bottom, where we have the lowest rocks of the Grand Canyon supergroup, reflecting the erosion and denudation of 20 kilometers through Earth's crust. That is the greatest part of the great unconformity from that point of view. And then we have smaller amounts of time missing as we move up, even to this very corner where we find that there is not really much of a gap at all. And in fact, the uppermost rocks that were considered part of the Grand Canyon supergroup are now known to be actually Cambrian in age. Holmes, William Henry Holmes, we saw a lithograph of his this morning in the first keynote address. Beautiful depiction of the rock layers. On the right-hand side, this is a panel from an exhibit at Grand Canyon National Park where illustrated for the general public is this concept that the lower part, the nonconformity within the great unconformity, reflects a huge stripping and denudation. And then the second phase would be the deposition of the Mesoproterozoic rocks across a denuded surface, and then faulting and tilting of that, and then the Cambrian deposition of the Tonto group. So the different phases of the unconformities. To think about the scientific tradition of recognizing the unconformities and their meanings in Grand Canyon history, John Wesley Powell, who performed the first scientific exploration of the Colorado River by accessing with rafts and quite a bit of trepidation as they traveled the great unknown. And here on the left is a scientific drawing from 1975, but it wasn't quite exactly right. If you were to look at this lower part here, we couldn't have the tilted sedimentary rocks and a flat-lying unconformity, so Carl's kind of redrafted that in proper format with, of course, the basal nonconformity tilted along with the Mesoproterozoic section. In terms of reasons and some of the ongoing scientific breakthroughs and changes in paradigms, we have a new type of geochronology, that is thermochronology, that helps us understand by looking at the past temperature or the time at which rocks cool through critical closure temperatures. The thermochronometers allow us to quantify the denudation episodes. And in fact, some of the most exciting scientific controversial literature in the last 10 years about Grand Canyon have been related to the understanding and interpretation and the changing paradigm of understanding denudation processes and erosion. And what better place to test these new tools for the geoscientists than at a place like Grand Canyon. So this is an exciting stage of development. Shown in the graph on the left is the way we would present thermal chronology results. Just as an example, one of the newer methods using zircon helium that shows it's able to parse out that early great denudation of the 20 kilometers prior to the deposition of the first supergroup rocks, and it also recognizes the great stripping done more recently by the Colorado River. Whereas the intervening parts, the merely 4 kilometers of deposition and erosion that happened during the Meso and Neoproterozoic, it does not seem sensitive enough to deal with that part of the burial history. So this is an exciting stage of developments scientifically. Other tools like thermal ionization mass spectrometry applied to suites of detrital zircons, where now geochronologists, where once before they had to do a whole rock on a basketball size of rock, now we can do thousands and thousands of detrital zircons from individual samples, and that type of work is leading us to use, to better understand the time, for example, in the Cambrian, and recognizing this new twist of some tilted Cambrian rocks, once thought to be Precambrian based on the field relationships, now recognizing that they're Cambrian in age, overlined by the Tonto group. So this is the not so great unconformity beneath the Tonto group. One of the aspects we haven't really heard as much about in the presentations that I've seen so far is the idea of public outreach to the geosciences. And here in Grand Canyon, we have the Trail of Time, which is a walking timeline. 1 meter is 1,000,000 years. It's an accessible trail along the South Rim using the spectacular vistas of Grand Canyon, and then beautiful specimens, large specimens, cut and polished so that people who are unable to climb into the canyon and see it firsthand are able to see the various layers up close and personal. And they also, in a more subtle way, see that areas of the trail are dotted with rocks when we have a good preservation of the strata, and then there are long, long stretches where there are no rocks. And it provides a very visceral feeling of the meaning of unconformities. So arguments for the recognition. I also want to make a call out here for indigenous scientists, traditional ecological knowledge, and recognize that the park where we're talking about today is the indigenous homeland of 11 associated tribes who now are working in concert with Grand Canyon National Park and the U.S. Park Service to start to incorporate a stronger indigenous and First Peoples view of the region and provide more engagement. We heard about Hutton and his cyclical idea. This is also very prevalent in many of the First Peoples' view of the geological history of the region in the Colorado Plateau. So we designed a medallion. Rock captures time, time carves canyon, canyon reveals rock. And so this idea of cyclical nature and also a linear timeline, combining the sort of Western traditional view and the indigenous view. I'm sorry that I missed my picture on the right-hand side. For some reason, it didn't come through. It was a photograph of some of the indigenous scientists that we work with at our institution, the University of New Mexico. We've trained 5 women who now have gone on to obtain eventually a PhD in the geosciences, and we're very excited to have their participation in the scientific endeavors moving forward. And I think in some ways Grand Canyon, I hope, can be a model for that type of diversity in the geosciences as well. Thank you for your attention.